Everyone. Because of the Scantron testing, just record our notes for today so that you can watch them as soon as you get done with your tests. So this is finishing the last couple of examples of 6.3, and then we're going to start and do the first page of 6.4 notes. And you've already gotten this, unless you just want to go back and watch it because you forgot. So this is mainly for my B3 block today. If you find your 6.2 notes, this is what it looks like. Okay, here's our 6.3, excuse me. Here's the top of the page. We've gone through the addition and subtraction, and we've gone through the multiplication. So where we're at is at the bottom of the page and under radical conjugates. I would like to remind you is that radical conjugates are conjugates in general are things that are the same, opposites of each other. Okay, same but opposites. For example, if I gave you a plus the square root of b, right, its conjugate. I'm hoping that by now you'd be able to tell me that the conjugate is a minus the square root of b. Conjugates are what kind of properties do they have? We're going to take these two conjugates and we're going to multiply them. So we're going to multiply the square root of b times a minus the square root of b. Okay, and when we do this, we're going to see what happens. So I'm going to start first times first. If first times first, a times a is going to give me a to the second. Then I'm going to multiply a times negative square root of b, and that's just going to be negative a square root of b. I'm then going to come to the inside, so I have positive a times the square root of b, which is just positive a times the square root of b. And then lastly, I have the square root of b times the square root of b, and there's a negative, so I have negative b squared. Now what's cool about multiplying radical conjugates, if you notice we have negative root b and positive root b, and those two things are going to cancel. What I'm left with is an a squared minus square root of b squared. And in relation to my FOIL, if I come, here is my first, my inner, my last. The inner and the outer pieces both cancel. And what I'm left with is b squared minus the last p squared. Okay, and we're going to use this when we get to this division in just a second, because this is going to help us kind of shortcut what we're going to do a little bit later. Okay, so we've got information on radical conjugates. So we're now going to talk about how we're going to use this radical conjugates to help us with our division. Division is kind of the weird part. Addition, subtraction, multiplication, that's not really anything new or crazy, but when we divide denominator, we do things a little bit differently. So division, the way that we're going to word this is the same as we're going to fancy one. That means by the radical conjugate of the goal in division so that there are no more radicals in the denominator. Okay, so we're going to fancy one by the radical conjugate of the denominator. When we do that, the denominator by its radical conjugate, when it comes to multiplying, we can use our shortcut. We're just going to take the first term squared minus squared. If there's more than one piece on the top, however, we're actually going to have to go ahead and go through the whole entire boiling process. Okay, so with this, we're going to go to your second page. And we've done all the first problems. The only ones that we haven't finished are the last two on the bottom. So today we're going to focus on this problem down here. Okay, so starting with the first one. I see that we have a denominator or a radical in the denominator, excuse me, and there's more than one piece. And when you see this radical in the denominator, we know we're probably going to have to fancy one. And since there's more than one piece, we're going to multiply by its conjugate. So if I have square root of 3 and square root of 5, 3 and square root of 5, this negative is going to turn into a positive. Okay, what's cool about that is when we go to multiply, we can now go first squared minus last squared. So I've got root 3 times root 3, which is minus square root of 5 times square root of 5, which is just 5. And we no longer have radicals in the denominator, which is kind of like our... But to keep this from changing value, this is what we call our fancy one piece. To the bottom, I have to come to the top. If there's only one piece here, we're just going to distribute. So I'm then going to multiply 2 root 7 times square root of 3, which becomes 2 square root of 21. Square root of 7 times square root of 5 becomes 2 square root of 35. Okay, since these radicals don't match, we can't add them. We have 2 root 21, 2 root 35, and then 3 minus 5 gives us negative 2. Last piece, if you want to mentally, we're going to take this negative 2 and put it over each piece separately and see if they simplify. So 2 goes into negative 2 and we're left with negative 1. So we've got negative root 21. Again, negative 2 goes into 2 and I'm left with root 35. My final answer is negative root 21 minus root 35. Okay, so we're going to look at one more like this. Okay, the last one, directions say rationalize the denominator, which is pretty much the same thing. Process. Notice that there's a radical on the bottom, so I'm going to have to fancy one. And since there are two separate pieces, I'm going to have to fancy one by the conjugate. When we do this conjugate, we use the denominator. So I'm going to put 2 square root of 2. The denominator has an addition sign. I'm going to use a subtraction sign. And we said the shortcut to multiplying conjugate is first squared minus last squared. So I've got 2 times 2, or 2 squared, which gives us 4. Root of 2 times square root of 2, which just gives us 2. On the bottom, I also have to come put on the top. Since we're multiplying binomial by a binomial, we're actually going to have to go through the entire numerator. Okay, so I'm going to start with 2 times 2, 4. And 2 times negative root 2 is negative 2 root 2. Come to the inside, negative root 2 times 2 is again negative 2 root 2. And negative root 2 is a positive 2. And we're now going to combine like terms and see what we can kind of clean up. So on the top, I have a 4 plus 2, which I can add together and give me 6. Right here, be careful, because if these signs were opposites, they would cancel. But since they're the same, we're going to take -2 minus 2, which is actually -4, and just tack on square root of 2. Okay, on the bottom, 4 minus 2 gives us. Now the last step is to see if we can simplify these fractions. 2 goes into 6, 2 goes into -4, -2 times, and then we tack on our square root of 3, and here's my final answer. I have no more radicals, which makes this okay. Okay, so that was the only thing from 6.3 that you maybe didn't have a chance to complete. Look at 6.4. And we're just going to look at this first page. Okay, so starting with the top. Up until this point, we have not been able to radical expression, that didn't have the same index. So this is our way to get around that in just a little bit. So put in the blanks for starters. Is that we can use and radicals. So we're not going to be able to go back and forth. We're going to use exponents and radicals interchangeably. Okay, so here's how it works. If I wanted to write the nth root of x, the index becomes the denominator of this fraction, okay, of a fractional exponent. So similarly, if I have x over n, now we just have another number other than 1. Now I wanted to rewrite it, becomes the denominator of a fraction. Okay, and then the second number, the m, can either be on the outside of the radical or on the inside of the radical. It doesn't matter. Okay, so what I would like you to write at the bottom is that the index becomes the denominator. Okay, so the index becomes the denominator. In my opinion, one of the challenging parts of this chapter is to know when to use exponents and when to use radicals. So 9 times out of 10, we are going to use when they have the same base. We're going to use radicals when they have the same index. Exponents when they have the same base. We can multiply radicals when they have the same. We're going to look at just a few problems here. Okay, starting with this first one, we have 7 to the 1/2 times 7 to the 1/2. So we're going to talk about the 2 ways that you could do this. Okay, option 1 is to use exponents, because we have 7 as a base and 7 as a base. So I can write this as 7. Okay, when we multiply exponents or powers, with the same base, we add their exponents. 1/2 plus 1/2. 7 to the 1/2 plus 1/2 is 7 to the 1st, and 7 to the 1st is just the number. If you don't like that, then you also have option 2. Option 2 is to write 7 to the 1/2 as a radical. And we said the denominator gets bumped to the index. So 7 to the 1/2 is the same as the 7 times the square root of 7. Okay, square root of 7 times square root of 7, and you don't have to write the 2 if you don't want to, is the square root of 49. And the square root of 49 takes you back to 7. Okay, so whether you go here or you go here, you're going to end up getting the same answer. Okay, which leads us to second problem. Problem looks similar, but if you notice this time, we have a 3 and a 12, so we have different bases. Base, we cannot use option 1, or we cannot use exponents, so we're going to use radicals. So I'm going to rewrite this. We said 1/2 is the same as the square root, so I've got the square root of 3. Similarly, I've got the square root of 12. When the index matches, we can multiply this. So this becomes the square root of 3 times 12 gives me 36. By this, because we know that the square root of 36 is just 6. Okay, so next we have C and D. And here's how we're going to approach C, and there's probably different ways, but in our mind, okay, when we see this to the 1/3, we know that 3 becomes the index, the cube root of 216, which means that we are looking for 3. I'm going to take 216 and I'm going to start to break it down. First thing I notice is that 4 goes into 216, so we've got 4 times 54. Okay, 4 is the same as 2. Okay, 54 is the same as 6 times 9. The same as 2 times 3, and 9 is the same as 3 times 3. Okay, so I'm looking for groups of 3. So I notice, first of all, that I have 3 2s, and I have a second group of 3 3s. So when I get ready to write this, I'm going to take out my 2s, 3s. But look, there's nothing left on the outside. And so 2 times 3 gives me a final answer of, okay, so now that leads us to D. And if you look at time, the denominator of these fractions are not all the same. So if we convert them to index, we're not equal to each other. Okay, so then we say, okay, well, maybe we look at these numbers. Well, we've got 3, and we've got a 27, and those don't match. So here's what our goal is. Try to get, either we're going to try to get the same index or the same base, and to avoid dealing with fractions, we're going to try to get base. And we're going to try to get the same base. So I'm going to start with down, so it's as small as it can be. So 3 is just 3. Is 3 times 3, which can be written as 3 to the second. 27 is 3 times 9. We said 9 was 3 times 3. So 27 is 3 to the third. So here's how this is going to work. We're going to replace 3, well, we're going to leave it. So we've got 3. 9 becomes 3 to the second, and the denominator is still going to be 27 becomes 3 to the third, with the denominator of. Now that they'll have the same base, we can say, okay, well, when we multiply with the same base, we add the exponents. Plus 2/3 plus 3/2. And this right here becomes, so if I look at just the top, I've got 1/3 plus 2/3, which is 1. We've got 1 plus 3/2. If I want to add these, I have to have the same denominator. So to make 1 have a denominator of 2, it becomes 2/2. 2/2 plus 3/2 gives me 5/2. So my final answer that I'm looking for is 3 5/2. And it's what I'm looking for. All right, so we just have a couple more. Example 2 with variables. And if you notice when you look at it, have the same index. We've got a 4 and we've got a 6. Okay. Side, they both have a base of x. So I'm going to write that they have the same base. And the base is x. Same base means that we are going to use exponents. Practice. I'm going to take this 4 and I'm going to make it a fraction. So this becomes x to the 3/4. I'm going to take the 8 and again make it a fraction. So this becomes x to the 2/8. We're going to reduce. So this is x to the 3/4. 2/8 becomes x to the 1/4. And rule of division means that we subtract. Minus 1/4 gives me x to the 2/4. Well, x to the 2/4 reduced to x to the 1/2. So, sorry, since the problem was in radical form, I've got to give my answer in radical form. Back to the index. Now my final answer, since 2 is implied square root, I'm just going to write it as the square root of x. Okay, so we're going to look at B now. Problem. We have a square root, which has an index of 2, and a cube root, which has an index of 3. However, they do both have a 7 on the inside. Okay, so again, same base, use exponents. So I'm going to write this as 7. The 2 becomes a fraction to the 1/2. The 3 becomes a fraction and becomes to the. Now that these match, we can add. So we've got 1/2 plus 1/3. The problem. Okay, getting these to be able to add. So plus 1/3. I need them to match. I can make 2 and 3 both become. Okay, the way 2 becomes a 6 is I multiply by 3. This becomes 3/6. 3 becomes a 6 by multiplying by 2, so it becomes 2/6 plus 2/6 becomes. So I now have 7 to the 5/6. But again, just like the problem above, since they gave us the problem in radical form, we've got to rewrite it in radical form. So the denominator now comes back and becomes the index. So my final answer is the 6th root, 7. All right, which leads us to the last problem here. The last one looks like it's going to be the most complicated, but it's actually not so bad. Okay, so here's what I think is kind of cool about these problems. Okay, I'm going to start to the third. So in our mind, that's now gone. I now have a fourth root. And the fourth root, we know if we want to rewrite it, becomes a fraction. We can ignore the fourth root. I've got a second piece, and it is a cube root. So again, the cube root is going to become a fraction. Mind, we can ignore the cube root. We've taken care of that. Left is we now have a square root. Square root becomes a, write a 2, put a 2. And we now taken care of every single one of those radical pieces. Use our rules of exponents. Power to a power to a power. We multiply the exponents. We multiply fractions, we multiply the numerator, so I have 3 times 1, which is, then we multiply the denominators. 4 times 3 is 12, times 2 is 24. And then we're going to see, can we reduce a 3 and 24 turn into 1/8? And then last, just like the last problem, since we're given the problem in radical form, we put it back in radical form. So the 8 goes back to the final answer is the x. Okay, so this is enough for what you need to finish your notes, is to finish 6.3 Excel. Start 6.4, you can, but we still have to finish our 6.4 notes, but you now have everything you need to finish 6.3